Hello and welcome to Getting Started with Teraslice. In this video we're going to do a quick overview of Teraslice and take a look at installing it, and we'll run a few jobs. One doing a simple data generation job, and then we'll do a data migration job just to give you a flavor of what Teraslice does and how it works. First up, let's talk about a little bit about what Teraslice is. It's basically a batch processing framework or companion to Elasticsearch. It takes the data out of Elasticsearch, slices it up, and then runs it in a distributed fashion so that you can do pretty much whatever you want to do with it. One of the biggest uses of this that we've used it for to this point is it's really great for re-indexing and migrating data at very high volumes. So by high volumes, what do we mean? Well, let's take a look here at this graph really quick. This is an example of a Teraslice job that we recently ran for one of our customers. This was migrating an index from a single cluster into multiple destination clusters. The index had a little over 70 billion records in it, and we ran a Teraslice job against this index that took about 13 hours, somewhere between 13 and 14 hours to process all 71 billion records and move them into actually 8 independent clusters. The job ran at a throughput of roughly 1.2 million records per second. And this graph can show you what Teraslice tracks, basically. We have slice states where each slice is tracked independently, and we can know whether a slice completed or whether it errored or whether it was just left pending, which is not a good state to see, but in this job we don't have any of those. So we see that it was pretty consistent around 1,000 slices per period, and which is about 10 seconds on this graph. And no errors, which is exactly what we want to see. The jobs that are run by Teraslice are basically a pipeline. Each step in the pipeline is tracked independently, so you have the throughput for each step. So in this, we call these ops, and in this case, there was Elasticsearch ID reader, and then it was a sender was an Elasticsearch bulk sender. So each of these was processed, and we tracked the throughput of those independently on this graph, and I think I mentioned it, but this is about 1.2 million records per second is what this graph translates into. And then we also track the time for each operation, so this allows you to see the performance of the individual operations as the job is running. And here, each of the reader operations was roughly about 3 seconds, a little over 3 seconds per read, but it's running many of those concurrently, which is where the relatively high throughput comes from. And then the bulk processing, which was the other big time consumer in this particular job, was a little bit under a second for each slice of records that was being transitioned. So this is a fairly significant job. The framework runs at pretty much any scale. It can work on just about anything that Elasticsearch can handle. So let's take a look at what's required to install it and get it running. We're going to be running on a single node for this example, and for that we just start off with we don't need Safari, we want Chrome, and we need to go clone the repository. So we just need the URL. And a simple git clone. Teraslice has 2 dependencies. It depends on Elasticsearch, and it depends on Node.js. And for this particular example, we'll be using Node.js 4.5. It requires Node 4 or above. So we've cloned the repository. This is a Node application, so we need to install the dependency modules using npm. And so this will kick off and install these modules. And while that's going on, we're going to start 2 Elasticsearch clusters. So we're going to do a demo of migrating an index from one Elasticsearch cluster to another. These are both going to be single node clusters running on my laptop here. So we have two clusters or two Elasticsearch instances here ready to go, conveniently named Elasticsearch 1 and Elasticsearch 2. So now those are starting up, and we come back over here. Our modules have finished installing, and so Teraslice is now basically installed. Not a whole lot to it, but to get it running, we now need a configuration file, and Teraslice will come with some example configuration files in the examples directory. In this case, it's a single node, so we'll use this processor-master file as the starting point. This is fairly simple. And the only thing we need to change for our particular configuration is we're going to have two Elasticsearch clusters. So we're going to add two additional clusters here. We'll name one ES1 and one ES2. And this second cluster is on port 9201. First cluster is on port 9200 as the default. In this instance, this is all very simple, but this list of hosts in a real environment can be as long as it needs to, and the number of clusters that are listed here in the Elasticsearch clause of the configuration can also be as many as needed. And it actually supports connectors for various other things as well. So there's connectors for Hadoop, and we have Kafka, I believe, and a few other things, and just about anything can be created. So we've saved this. Now we can go and start Teraslice. So we just run node with the service file, and then we give it a path to the configuration. And it will start up for the first time. And the first startup, it has to create its indices. So if we look at Elasticsearch now, we'll see that there is a TeraCluster jobs index. This is where Teraslice will store the jobs that are submitted and track their execution and state as they're running. Once a job is submitted, it will also create a couple other indices, which we'll see shortly. But in order to make this a little bit easier to see, we can also stop this. Teraslice uses Bunyan for logging, so we can pipe this through Bunyan, and we'll get a little bit friendlier presentation of the log output. So the first job we're going to run is a data processor job. So again, under examples, we'll start with the example job called conveniently datagenerator.json. This is a persistent job, which means that once it's submitted, it will just continue to run, and it just basically iterates and generates data for as long as you leave the job running. It generates, each iteration of the job generates 5,000 records, and we're only going to run it with a single worker, but you could run it with as many workers as you want. And this is actually really useful if you want to do something like load test an Elasticsearch cluster. So if you run multiple Teraslice instances, put them together in a cluster, bring up a data generator job with, say, 50 workers, it can generate millions of records per second worth of load to benchmark or stress test an Elasticsearch cluster, which can be a really useful thing if you're doing things at large scale. So basically, this just generates the data 5,000 records at a time, sends it into the index selector, which is going to put it into a index named example logs, type events, and then it generates, or it sends Elasticsearch bulk requests 5,000 records at a time. It's fairly straightforward. We're also going to add one little thing here. We'll go ahead and be explicit about the connection that we're going to use. So we'll say ES1, since we want to generate it into our primary Elasticsearch cluster. We save that, and in order to run the job, we simply do a post to our Teraslice instance, jobs. And this is going to be Teraslice examples, config, not config, jobs, and data generator. And get rid of this, and the job will submit and start to run. So when the job is submitted, you get two IDs back. The first is the job ID, which is what represents the job configuration within the system. The job configuration and the job execution live independently. So for instance, you could submit a job that you don't actually want to run, you just want to store it in the system and then start that job later. Or you can submit the job, let it run once, finish it, and then restart that same job later. Each time it runs, it gets a new EXID, which is the execution context of the running job. So now that we have a job running, we can take a look at some of the other endpoints that are exposed from Teraslice. First, we can take a look at nodes. We only have a single node. You can see it's running Teraslice version 06, and nothing too exciting there. We can also take a look at workers. We scheduled this job with a single worker. So we get, by default, we get a cluster master, which is what controls everything. And then each job gets a slicer, and then however many workers are allocated for that job. In this instance, it's a single slicer and a single worker. And the job is just continuing to run. If we take a look at the cluster now, we'll see that there's a example logs index, which has 125,630 records. And as we look at that, it'll see that that number will just keep increasing. And that's about enough data. So what we want to do is we want to stop this job. So we need the execution context ID. And this is going to have to be a post. So we post to that. You'll see up here in this window the job will stop. It has now stopped. And so if we take a look at EX, which is the execution context, we see that we have one job. It was a persistent job, one slicer, one workers, and the job is stopped, which was the command that we gave it. So now that the job is stopped, we have a little bit of data. We can go see how much did we get. We got 180,000 records. And now if we take a look at the second Elasticsearch index, we have our Elasticsearch cluster, we have nothing there. So now we want to create a job to migrate our 180,000 records from our ES1 cluster to our ES2 cluster. Okay, before we get into creating the reindexing job, let's take a quick look at the data just so we can see what we have to work with. And we'll do pretty so that it is somewhat readable. As we see, this is basically like a HTTP log entry, just synthetic data. You have IP address, user agent, URL, common things like that. We also have a created date, and this is the most important thing for us as far as wanting to migrate this data to another Elasticsearch cluster. So we'll hop over to our example jobs again, and we will start with the reindexing job. In Teraslice, reindexing and migration are more or less the same thing. So we'll give it a name. We're going to migrate from ES1 to ES2. This is going to be a once job, which means it's going to run through one time and then finish. We'll give it 2 workers just so that we can see how that works. The first operation is the Elasticsearch reader, and this will use a date range slicing algorithm to slice the index up and then process it concurrently. So this is where the date field name comes in. We're using created. Our type here is events, and our source index is example logs. The size is what determines the rough slice size. It doesn't mean it's going to be exactly 10,000 records. It's going to just try to hold the slices to around 10,000 records. A lot of times it'll be smaller than that, but it comes down to what the date range, or the interval works out to be. So for for this, since we're reading from ES1, we need to add our connection to ES1. Once the reader gets a slice of data, it will then pass it through the index selector, which will set up the bulk request and send it to an index called example logs new. We don't need this ID field, so we'll get rid of that, and we'll correct this type since our type is called events. And once the bulk request has been set up, it'll be sent to the Elasticsearch bulk sender, and we want to send this to ES2. So the main difference between reindexing and migration is just the destination. If we change this to ES1, it's reindexing. If we change it to ES2, it's doing a migration between clusters. A few other things to note while we're here. The Elasticsearch reader has many options that you can set on it. For instance, you could say query, like you wanted to pull a subset of the data out of a larger index into a secondary index for deeper analysis or something like that. For instance, if you're interested in a particular IP address or something, you could, but it's not really a valid IP, is it? But whatever it is, and you put this into the job, and it will then select only records that match this query. You can also put in date range restrictions and various other things. There's quite a few options for this to configure it. There are also other slicing algorithms available besides date range slicing, and we'll be adding more of these in the future. But for now, this should be good, and so we can go back to our Teraslice instance, and we want to post this job again to the /jobs endpoint. This is examples jobs reindex. Get rid of the space again, and the job will now start up and will begin to run. This initial output is coming from the slicer as it determines the slices that it can utilize. And if we take a look at some of our endpoints on the Teraslice instance, for instance, if we look at workers now, we should see that there's one slicer and two workers. There's also a slicers endpoint, which will give us some information about the slices that are existing. It looks like this job's just about done. I bet if we look up here, it's probably completed. So it processed a total of 24 slices using two workers. In this instance, we caught it right at the end of the job, so there were no actual workers active, but they were available. The job wasn't quite done. If we look at it now, the slicer will be gone. And if we look at EX, this is our execution context, we'll see that there's migration ES1 to ES2 as a once job, one slicer, two workers, and the status is completed. So the job did finish successfully. And if we go back over here and take a look at our source cluster, we have 180,000 records. And if we look at our destination cluster, we should find 180,000 records there. And so those should be exactly the same. And well, that's about it for a quick introduction to Teraslice and a simple data migration task for moving data between two clusters. Obviously, 180,000 records isn't that big a deal. This tool is designed to work with millions or billions of records. And hopefully this has been informative, and we'll talk to you next time.